All right, this is question number 4 of the exam. So I'm going to go through this step by step. So let me get rid of some of the highlight that we don't need. There we go. All right, so let me read the question first. There are 10 potions, of which 4 are cursed. So that means there are 10 potions altogether, 4 are cursed, and then the other 6 are not cursed. Fatality occurs if and only if cursed potions are consumed in one and only one specific order. So that's going to be explained next because at this point we have not identified the potions, which one is cursed and which one is not. So it's hard to specify the order. But even if the other potions are consumed in between, for example, if potion W is not cursed, potion X and Y are cursed and fatal if consumed in the order of X before Y. So in this case, it's an example. X and Y are cursed and W is not. And it's only fatal when X is consumed before Y. So that's just an example. All right, so let's switch to answer mode so that we can actually answer the questions. If consuming all Z potions in a non-repetitively is an experiment in a non-repetitive way, as an experiment, uh, what is the number of trials? So there are altogether 10 potions. So that means if Z, which is also 10, is the answer to this particular part. Part 2, what is the number of outcomes for the first trial? There are 10 potions altogether, so there are 10 outcomes. Um, and then the next one is, are the trial outcomes with or without replacement? The answer is without replacement. Um, and the key here is non-repetitively. Okay, this is kind of the key word to help us, identify that we are talking about the actual potions and not whether they are cursed or not. Because just being cursed does not mean it's fatal. You have to do it, consume it in a specific order. So, if fatality is to be considered, are experiment outcomes ordered? The answer is yes, because drinking um, the potions in a specific order, in one order it may be fatal, in the other order it may not be fatal. And then part 5 is to derive the cardinality of the experiment outcome. So that is really just 10, choose 10. Uh, excuse me, it is the number of permutations of starting with 10 potions and choosing all 10 potions. So that's which is also simply in this case it is the same as z factorial. There we go. Because I'm supposed to reference the variable names, so that's why I have to use z factorial in this case, and the tens should be z as well. Let me go ahead and fix that. Mhm. So there's z to begin with, and we want to choose z where ordering is important. And here comes the more difficult part. Let the let us number the potions from 0 to 9. So that's just a way for us to identify the potion 0, potion 1, and so on, and designate the cursed potions as potion 0 to potion 3 in this case, because we have 4 potions that are cursed, so they are the first 4 potion. Let the symbol x of I be the 0-oriented sequence number of consuming potion I. For example, x subscript 3 equals to 1 means potion 3 is the second potion to be consumed. A universal constraint is that for every I there's a natural number and I is less than z, because z is 10. So because everything is 0 oriented, so we're basically talking about I going from from 0 to 9. X of I has to be a natural number, which means the order itself has to be a natural number, and x of I has to be less than z, which means the mm, sequence number of when this potion is consumed has to be less than 9. It has to be 0 to 9, basically. And the additional constraint of fatality is that for all I in N, and I is less than W, so in this case, it's basically saying I has to be from 0 to 3 as a quantifier. X of I has to be less than x of I plus 1 because that specified that we consume potion 0 before potion 1, and then we consume potion 1 before potion 2, and then potion 2 before potion 3. So those are the constraints, expressed as a quantified expression. And then part 6 is asking explain and derive the general formula using the variables introduced to express the number of ways to position the consumption of cursed potion leading to fatality. For example, if there are four potions of which two are cursed, then these six specific ordering of the cursed potion will be fatal, regardless of how the non-cursed potions are consumed. All right, so moving on to the next page. Oh, okay. And let me see if I can get rid of this. There we go. All right. Um, do not, do not take the positioning of non-cursed potions into consideration for this part. So that's number 6, and there's a little bit more space here to kind of answer the question. All right. So one thing is to notice the pattern here. We have 0, 1, 0, 2, 0, 3, 1, 2, 1, 3, and then 2, 3. And if anything, you might notice that these are also the outcome of combinations of 4, choose 2. In other words, if I have a bag that has the numbers from 0 to 3, so 4 pieces of paper, and I say, okay, how many ways can I choose 2 pieces of paper out of the bag? Then you go like, okay, it'll be the same as the sets, but in this case, it will be a set of 0, 1, a set of 0, 2, a set of 0, 3, a set of 1, 2, a set of 1, 3, and a set of 2, 3. That is correct. Those are sets, not tuples. However, in this case, there's a 1-to-1 correspondence. So I'm just going to say, okay, there. Oh, okay, I meant to say there. There is a 1-to-1 correspondence between um, the combination and um, ordering of cursed potion consumption. And as a result, the answer to this question is going to be the number of combinations. We are basically looking at 10, and we are choosing 4. So the 10 is representing, or in this case, which is, I kept using the actual number. Okay, so let me fix that. Okay, we're not supposed to be using the actual number here. So we are supposed to be using the variable names. So that would be, let me see, I cannot remember the symbol, ZW. Okay, so we're looking at Z, choose W. So the Z is basically, giving us all the positions that are possible, 0 to 9. And then W is giving us the number of things that we have to choose from those particular positions. But it will only return, the number of combinations, which normally is each combination is a set. However, all we are doing is we are looking at a set and then we convert it into a tuple where the elements are sorted. Now that is a one-to-one correspondence because a set cannot contain duplicate elements. So that means and integers or natural numbers are they're ordered, fully ordered. So as a result, we can always look at each set and then convert it into a unique tuple, and it's a one-to-one correspondence. So that's how we answer part six. And then for part seven, for each fatal way to position the consumption of cursed potions, how the non-cursed potions are consumed is inconsequential in terms of leading to fatality. So I'm using an example here again, using the four total potion of which two are cursed as an example. And in this case, I'm particularly looking at the case of x0 equals 1 and x1 equals 3, which basically means the potion 2 and potion 3 are positioned, excuse me, potion 0 is consumed second, and then potion 1 is consumed last. But the whole point is it is still fatal because, potion 0 is consumed before potion 1. But then we have the first and the last position being unspecified, and those are for the non-cursed potions. So that means, however we want to position those non-cursed potions at position 0 and position 2 of the consumption order, the whole consumption, of all four potions is still going to be fatal. So in this case, I also kind of very specifically say, okay, so in this case, x2 equals to 0 and x3 equals to 2, which means the third potion is consumed first, and then the last potion is consumed third, versus uh, the third potion is consumed third, and then the last potion is consumed first. So those are the two fatal ways, to position for each. Okay, let me. The last, second to the last, sentence says, for each fatal way to position the consumption of cursed potion, how many ways can the non-cursed potions be positioned, and derive it using the variable names. So in this case, ordering is important, and as a result, we have Z minus W potions to be positioned, and as a result, the answer is Z minus W, the whole thing factorial. But you can also say that this is the number of permutations of having all the non-cursed potions, and we are basically saying, okay, how many different ways can we pick the non-cursed potions out of the collection of non-cursed potions, because the remaining positions that are available for the non-cursed potions is already fixed, because we have already specified this is for each way to position the cursed potions. So that's why in this case the number is, you can either specify as Z minus W factorial, or you can specify the number of permutations of Z minus W, choosing Z minus W from Z minus W. In other words, the other way to say this is to have a P here, and then you specify Z minus W as the suffix, and also as the uh, not the suffix. This is called the subscript and the superscript. There we go. Okay, part 8. Let the event set E contain and only contain ways to position the consumption of all potions leading to fatality. Each element is in the form of a tuple of values in the format of x and 0 to x subscript z minus 1. So we are basically looking at a tuple where each number in the tuple is specifying the order or the positioning of the consumption of the potion of that position. Um, So I have another example here to specify this. Using the result, I'm reading the last sentence now. Using the results of part 6 and 7, explain and derive an expression that computes bar E bar. So bar E bar is the product of part 6 and part 7. So this is going to be ZW times Z minus W factorial. It's Z choose W. That would give us the number of ways to specify the positioning of the cursed potion to end up with a fatal um, ordering of all potions. But that's just accounting for ways to position the cursed potions. And then Z minus W is giving us Z minus W factorial is giving us the number of ways of how we can position the non-cursed potions for each way of positioning the cursed potions. So that's why when we multiply these two, the product is representing the number of ways to the total number of ways of positioning all Z or 10 potions in this case to end up with fatality. And then part 9 is calculating the chances of dying from drinking all the potions in a random order. So this would be the probability is the cardinality of E divided by the cardinality of omega. So in this case, since we have already solved part 8 and also the earlier parts, which is part 5. So part 5 gives us the denominator, which is the number of permutations of choosing W from Z, and then the part 8 is giving us the uh, numerator, which is Z choose W times Z minus W, the whole thing factorial. So this is the actual equation, and then to compute it, it is going to be, in this case, 10 choose 4 times 6 factorial, and then the whole thing divided by, um, let's see, this is 10 factorial divided by, let's see, 6 factorial. Let me see. Yeah, it is 6 factorial here. Um, yep. So there are other ways to simplify this too. Because with the numerator, it is 10 factorial divided by 4 factorial times 6 factorial, and the whole thing times 6 factorial. These two cancel out. Divided by 10 factorial divided by 6 factorial. There we go. That doesn't look right to me. Something is amiss. Because okay, so somehow my math is not right. Because the way it works out right now is the numerator is actually going to be larger than the denominator, which is not possible when we're looking at a probability. So let me just double check my math here. The cardinality of E is Z choose W times Z minus W factorial. That is correct. And then Z choose W is 10 factorial divided by 4 factorial times 6 factorial. That is correct. Z minus W factorial is indeed 6 factorial. And then those two cancel out, and we ended up with 10 factorial divided by 4 factorial on the top. And at the bottom, we have 10 factorial divided by 6 factorial, because that is the number of permutations of. Oh, no, no, no. Okay, I got that wrong. Okay, never mind. Because it is not. Uh, okay, when we look at the answer to number five, it is z choose z. So I was incorrect. I remembered incorrectly. So this is actually just 10 factorial itself without anything. There we go. Cool. Okay, now it makes sense because now the denominator is definitely larger, and the actual answer is surprisingly um, simplified because now we have 10 factorial canceling out the 10 factorial here. So this actually just turns out to be 1 divided by 4 factorial, which is in our case, if we want to use the symbols, it is 1 divided by w factorial, which is 4 factorial is 24. So this is basically the same thing as 1 divided by 24, which is approximately what 4 point something percent. Okay, that's okay. That works out. That's the answer to I guess the most complicated question of the entire thing. So I'm gonna work on the other ones later, but I'll turn this one in and push it on the YouTube.